welcome to the video. Today we are going to be talking about how we get nutrients and whatnot. This is going to be kind of a long topic, so it might be spread out across a couple of videos, but today it's going to be a little technical, but we're going to get through it. So the idea that we consume foods and how we get our energy source is actually from the sun. So what happens is that the sun provides energy to like plants and whatnot, and then the animals, they eat the plants, and then of course we eat the plants, and then after that, to get more proteins, we eat animals. So how the breakdown goes is that you have about 40 to 50% of carbohydrates, you have about 40 to 50% of fats, and then the rest of that, kind of like that 20% gray area, is the protein and whatnot. So I'm gonna go into a little bit further in detail about ATP, CP, glycolytic pathway, oxidative pathways, a lot of technical stuff like that, which we're gonna sit down and actually talk about, because it's kind of it's definitely more technical and very intensive like that. So I think taking the time and slowing down and making sure we get the material across, efficiently. Okay, so we're going to be talking about metabolism and kind of defining how it works through our body. So remember that metabolism is essentially how our body breaks down and builds up the things that we eat. So it's also like the rate at which we process food. So metabolism splits into two things: anabolism and catabolism. Anabolism is the building phase, and catabolism is the breaking down phase. So, this is the definition of like the chemical process that the body goes through to process food. So the food that we eat can either be burned as, or used as used for energy, or burned off as heat, added as body weight, or excreted out through the bowel system. Carbohydrates are what are broken down into glucose, and then from there they go into energy or protein. And protein is the most dominant, which is used for tissue and organ maintenance. So, and then after that, there's the ingested fats, which break down into fatty acids for energy as well. So, regardless of the source of whatever we eat, all calories in the excess of the body's energy needs. So this is like if we eat in like a caloric surplus and we have too much food to where we don't actually need it, and it's not being converted to energy, it's actually getting stored in the adipose tissues as triglycerides. Continuing from what we were previously talking about, so the breakdown of like the food stuff gets converted and is referred to energy metabolism, which is the series of chemical reactions in our body that kind of help produce the energy, and sometimes it'll give off heat. So when muscle contraction is necessary, the adenosine triphosphate, or known as ATP, which is what I'm going to be referring to the rest of the video, that is the molecule that has the energy stored up and ready for us to use. So we consume carbohydrates, we consume fatty acids, we consume protein, and then it gets stored in this ATP. So, and then this can happen in any three of the combinations of the metabolic pathways: the ATP/CP pathway, the glycolytic pathway, and the oxidative pathway. So these are the three ways that ATP can be formed by the muscle cells. Anaerobic metabolism is defined when ATP is formed with oxygen, is formed without oxygen. Short-term activities which require like a high intense interval kind of training, that's when ATP is utilized from the anaerobic energy pathways. So, and this is also when we use the ATP slash CP pathway, or the CP system, because what happens is that the phosphate gets separated from the creatine, excuse me, and reforms with the adenosine diphosphate to make the ATP. So, just for a better definition, one molecule of CP results in the reformation of one molecule of ATP. So this system is sufficient for about the 3 to 15 seconds, which is like your Olympian lifts, or like your main lifts, like your bench, your squat, your deadlifts that require a lot of effort in a short amount of time. So also the conversion of glucose to lactic acid happens in the non-oxidative glycolysis, and that is when one molecule of glucose results in 2 molecules of ATP. And then one molecule of glycogen results in 3 molecules of ATP. This system is reliable for the 1-2 minutes of maximal effort. So this is like if you guys were to do like sprints or burnouts. A type of burnout that would require maximal effort is if you were to do a wall sit, or if you were to do a plank hold. Typically about the 1 to 2 minute range, you would start to feel extremely fatigued, and where therefore you are requiring maximal effort. So stay tuned for more. Okay, going off of what we were talking about earlier with ATP. So when ATP forms with oxygen, this process is called the aerobic metabolism. This includes like the aerobic glycolytic pathway and the oxidative pathway. Long-term activities with like the low, moderate intensity utilize the ATP pathways. Just to spit some facts at you, the aerobic metabolism of one molecule of glucose results in the production of 38 molecules of ATP, and one molecule of glycogen results in the production of 39 ATP. So this means for aerobic and anaerobic exercises, glycogen is an important factor. So just remember that glycogen comes from the carbohydrates and the fats and the proteins that we ingest in our diet. So the glycogen will help power and fuel our workouts and exercises that we go on to. So this is mainly used for like endurance exercises, and the fatty acids is actually the primary fuel source for these types of workouts. One way that you can kind of help monitor your metabolism is through what the fuck was that? Sorry. Monitor through nitrogen test sticks, or like the handheld portable calorimeters that you can get offline. So hope you guys enjoyed the video. Please stay tuned for more. I got more stuff coming. If you haven't already, hit the like, hit the subscribe button, hit the notification bell so you guys get the future content of these videos. Peace.